Alright, so solving trig when in standard form, which is the a times sine of bx plus c plus d, or the other trig functions of cosine or tangent. Again, we want to isolate the trig function by getting rid of d and then a. Factor if you can, substitute with an equivalent expression using our trig identities, and then finally finish. Like inverse trig should be one of the last things unless you have more going on, like you have the bx plus c in there, and then you have to get rid of the b and the c. So this video is actually the video for section 6.4 where we solve in this form. So we're still going to be looking at trig identities, but the identities are going to help us write it down into standard form. Okay, so again, we're not going to worry about the real solution here. We're just going to go with this. So if you can look at this right here, we have 4 terms, which in terms of factoring back in algebra, that meant we would look to factor by grouping. So we group the first two terms together, and we look for a common factor, which is 4 sine squared. And then we look at the second 2 terms, and our common factor would have to be -3. And it's -3 because the 6 is negative. So then we factor this out. We have 4 sine squared times 2 cosine minus 1. And then over here we have -3 times 2 cosine minus 1. The 2 cosine minus 1 is the same, so we're going to go ahead and factor those out. And so now what our equation becomes is 2 cosine minus 1, that common factor, times what's left, 4 sine squared minus 3. Okay, so now that we know this and it's equal to 0, we can use our zero product property. So we set the first factor, minus 1 equal to 0, and then we set the second one equal to 0. And we solve. So add the 1 on that one, add 3 on the second one. So we get 2 cosine is equal to 1, and we get 4 sine squared is equal to 3. Divide by 2 on the first, divide by 4. So now we have cosine of x is equal to 1/2, and sine squared of x is equal to 3/4, which then we have to take the square root, so we get, sine of x is equal to plus or minus the square root of 3/2. All right. So let's start with cosine first because that one's easier. We know cosine of x is equal to 1/2 in the first and fourth quadrant. In the first quadrant, that is at x is equal to pi/6. Then in the second quadrant, and then our secondary one, or the one that's between 0 and 2 pi, would be that angle that's in the fourth quadrant, which would actually be 2 pi minus pi/6, which is 11 pi/6. Okay, so now in terms of the sine, we had plus or minus the square root of 3/2. So we've got to consider, remember sine is defined between pi halves and -pi halves. So we're looking at the solutions in the first and the second quadrant. In the first quadrant, sine is equal to the positive square root of 3/2 at pi/3. And then in the fourth quadrant, which isn't really part of the principal root because it's outside of the first quadrant, and usually we think of the principal root as being between 0 and pi, or to be able to keep track of the negatives and everything, or the positive values. So we would say that or the principal root, I guess, is the first root from the angle of 0 on. So the first root is at pi/3, and then in the fourth quadrant, it would end up being 5 pi/6 for negative square root, and then their secondary angles are at the 2 pi/3 and also at, sorry, that's not 5 pi/6, it's supposed to be 5 pi/3. I am stuck on writing 6s today. Okay, so and then the secondary one for 5 pi/3 is at 4 pi thirds. Alright, so for this one, we see that we have sine and cosine, but cosine is a double angle, so we're actually going to rewrite that using a double angle trig. So, and we want to rewrite it with sine, so we're going to use our double angle trig formula with just sine, which is 1 minus 2 sine squared of x plus 7 sine of x minus 5 is equal to 0. So this gives us 3 minus 6 sine squared of x plus 7 sine of x minus 5. And then we simplify this. We get negative 6 sine squared of x plus 7 sine of x minus 2. Then I always want my leading term to be positive, so I'm going to divide by negative 1. So this gives me 6 sine squared of x minus 7 sine of x minus 2 is equal to 0. Okay, again, I'm going to treat this like it is just a regular quadratic. I'm going to let u equal sine of x. So that means u squared is equal to sine squared of x. So I have 6u squared minus 7u minus 2 is equal to 0. I'm looking for factors of negative 12 that will add up to negative 7. That's negative 4 and negative 3. However you factor, this is just the way that I organize my factoring and how I teach my students to factor. Then what I do is I set up a leading coefficient with the variable minus the first number that I found, leading coefficient and the variable with the second number that I found, and then I divide here by whatever goes into both terms. So like, for example, with 6 and 4, both of those are divisible by 2. And for 6 and 3, both are divisible by 3. So this ends up factoring to whatever that's equal to, which is 3u minus 2 and 2u minus 1 equals 0. So that tells me that this factors to 3 sine of x minus 2 and 2 sine of x minus 1 is equal to 0. So now I can use my zero product property. So this gives me sine of x is equal to 2/3 and sine of x is equal to 1/2. Okay, so we know 1/2 exists on the unit circle. The first place, like in the first quadrant, it is in okay, in the first quadrant it is at pi 6, and then as we go around in the unit circle, the other place where it equals pi 6 is at 11 pi 6. Okay, so when it comes to this one, 2/3 is not on our unit circle, so we're going to do x is equal to the inverse of sine of 2/3, and we can plug that into our calculator, and we get the answer of 0.73 about, rounding that up. So then what this tells us is that's in the first quadrant. The other place where it's going to equal positive 2/3 is in the second quadrant. So to find that angle right there, we're going to do pi minus 0.73, which is equal to 2.412. I used the original number in there. So 2.412 radians, and that's how we find the principal angles and then the secondary ones, or all solutions from 0 to 2 pi. Okay, so this problem is a little different because we're going to state all the solutions within one period. So instead of from 0 to 2 pi, we are going to look at one period. So we need to be able to find the period of the function. So again, to find the period, remember we have to identify our b values. So we're going to factor out pi 12ths. So we're going to have, pi 12ths times x minus, and then pi over 4 divided by pi 12 is pi over 4. Let's do this over here. Pi over 4 times 12 over pi, which is going to give us the answer of 3. And then we still have cosine 1,235 and plus 772 is equal to 1,750. Okay, so our b value is equal to pi 12ths, which means our period is equal to 2 pi divided by pi 12ths, or 2 pi times 12 over pi, which is equal to 24. So we can basically say that we're doing this from 0 to 24. Okay, so starting with that, let's go ahead and start solving for cosine. So first we're going to subtract the 772 over. So we get 1,235 of cosine of pi 12 times x minus 3 is equal to 1,750 minus 772. It's a lot of sevens. Lucky number 7. We have the answer of 978. Then we're going to divide both sides by 1,235. So we get cosine of pi 12 times x minus 3 is equal to in terms of a fraction, it stays 978.1235, so we'll just leave it that way. So from this point, let's treat this like, instead, we're going to do this in a different color. Cosine of u is equal to 978 over 1235. And so the two places where cosine is going to be positive is in the first and the second quadrant. So that means that we're looking at, when we solve this one, we should get a value for cosine that is in the first quadrant, and then we should apply that to one that's also in the second quadrant. So we're going to do u is equal to inverse cosine of 978 over 1,235, and so that gives us an answer of 0.6569. So then what we want to do is be able to find these, not the second quadrant, sorry, because this is a positive u, we want the fourth quadrant. So this is the first, and then we want the fourth quadrant, which means we're going to do 2 pi minus 0.6569, which is going to give us a second angle of 5.626 3. So that's going to take us back to the two values that u is equal to. So we're going to say pi 12 times x minus 3, and that's our u value, and we're going to set it equal to 0.6569. Then we also have pi 12 times x minus 3, which is our, still our u value, which is equal to the other angle, which is the 5.6263. So now we're going to multiply both sides by 12 over pi of both equations, because we need to get rid of the pi over 12. I about made the same mistake. And so we get x minus 3 is equal to 2.509, which when we solve for x, we're going to get 5.509. Then over here, we get x minus 3 is equal to 21.491, which means we're going to get x is equal to 24.491. So what this tells us here is that this one is actually outside of the one period, However, what we do know from that is because that represents a point through one with one full period, we can actually subtract 24 from this, and we get the answer of 0.491, which gives us, sorry, I don't know why I did equals again, which gives us the actual second answer to this solution by taking the period away. So an x value of 5.509 and x equals 0.491 are the two solutions within the given period of 0 to the end of the period, or to 24. So again, I know this video is getting long, but I just want to reiterate the fact that what we did here is that cosine is going to have a positive value in the first and the fourth quadrant. So we did use substitution here, where we found just regular inverse cosine of 978 over 1235 is 0.6569. And then to find the second quadrant, we subtract this, and we end up getting the fourth quadrant angle is 5.6263. Then we use both of these by setting them equal to the original angle, what we were substituting for u. So pi 12 over times x minus 3 equal to both of those. We went through and we solved for x. The first one is within the period, but the second answer was actually outside of the period from 0 to 24. However, because it's bigger than 24, we can take the period away, one full period away, so it's like rotating one full rotation back, and we get the second answer that makes this one true. Okay, so right now it's in factored form, however, it is not written or equal to 0, so we have to subtract the square root of 3 over 2. So we get 2 tangent of pi halves minus x times sine squared of x minus the square root of 3 over 2 is equal to 0. Okay, so now this is where we're going to start using some of our trig identities. So this is 2 times sine of pi halves minus x over cosine of pi halves over x times sine squared of x, still minus the square root of 3 over 2. And then remember, this is really just saying complementary angles, so it's referring to the cofunctions. So we could rewrite this as 2 times cosine of x over sine of x times sine squared of x is equal to, or sorry, not equal to, minus the square root of 3 over 2 equals 0. And then a sine of x will divide out, and so we have 2 cosine of x times sine of x minus the square root of 3 over 2. Okay, so again, just going over this, first we substituted sine and cosine in for tangent, and then we realized that pi over 2 minus x, that refers to a complementary angle, so we changed it to their complementary angles, and then we multiplied to reduce the sine. So now if you remember, this 2 times cosine times sine is basically the double angle formula for sine. So sine of 2x is equal to 2 sine of x times cosine of x. And so that allows us to then substitute this back in. So we have sine of 2x is equal to, we're going to bring the square root of 3 over 2 since we just simplified this entire function to one trig function. Then we can do inverse trig of sine. Square root of 3 over 2 is in the unit circle. So this is when sine is equal to positive square root of 3 over 2. That is in the first and the second quadrant. So in the first quadrant, that is the angle of, sorry about that, that is the angle of pi over 3. And then in the second quadrant, that's 2 pi over 3. So that's like saying sine of u is equal to the square root of 3 over 2. And so we would get u is equal to pi over 3, which is what our calculator would give us. And then we subtract that from, so pi minus pi over 3, and that's where we get the 2 pi over 3. Just to remind you guys where those come from. So now what we do is we set 2x equal to both of these. Not square root of 3 over 2, I'm sorry. Pi over 3 and 2x is equal to 2 pi over 3. And we get the answer of x is equal to 2 pi over 3 and x is equal to 4 pi over 3. Which makes sense because we're talking about these being now in the second and the third quadrant with our double angle. So the double angle for this one would be in the first quadrant, would be moving it to the second quadrant, and then the double angle for the angle that's in the second quadrant would move it into the third quadrant. Alright, then finally let's finish with an application problem. So the volume of a cone is given by the formula V is equal to 1/3 pi r squared times h times sine of theta. So it's the sine of is what puts this into a trig course. So now if we just read in this, it says r is the radius, we know that, h is the height of the cone, and alpha is the complement of the angle of deflection, so when the cone is at a slant. So an angle of deflection is, if you picture the Tower of Pisa, this is kind of like the Tower of Pisa, and how far it's tilting, that is the angle of deflection. So it's this angle right here, which we're calling theta. The complement of that angle is, here is our perpendicular line, which also represents the height on both sides, and we basically find from the perpendicular to our line of deflection is going to give us alpha. So that's where the alpha comes from. Okay, then we have also our r, we have our h, and we've talked about where alpha comes from. Now you might be wondering, why do I need to know alpha if the equation is in theta? It's because they actually, in word problems, describe the angle of deflection. They don't give you the theta value. So that's why that's important. Okay, so now let's get to the word problem. As part of a sculpture exhibit, an artist is constructing 3 such structures, each with a radius of 2 meters and a slant height of 3 meters. Find the volume of the structure if the angle of deflection is 15 degrees, and then what angle was used if the volume of the sculpture is 12 meters cubed. Okay, so again, this problem is, when we're talking about it, we describe the angle of deflection instead of the 15, or the angle from the horizontal, or theta, in accordance with this drawing. So let's first talk about the volume. So we're trying to solve for volume, which means we're just going to do V equals, and we're going to plug in everything that we know. So 1/3 times pi. We're told that the radius has to be 2 for all of these. And then we're told that the slant height is 3. So we're going to do times 3 times sine. And then remember, theta is equal to the complement of the angle of deflection. So we do 90 minus 15. So then we just go through and go ahead and solve this. 1/3 and 3 will divide out. So we have 4 pi times sine of 75. Now when you plug this in, because this is in degrees, please make sure that your calculator is in degrees. 75 is not one of our terms or values on the unit circle. We could do a sum or difference for this, but because it's a word problem, having it as a decimal approximation is going to make more sense than an exact value. So I'm going to change my calculator into degrees, and then I'm just going to do 4 times pi times sine of 75, and I get the answer of 12.14, and it's measured in meters, so we'd say meters cubed. Now for the second problem, we have 12 meters cubed, and we have to solve for theta, and then we're going to use that to be able to solve for alpha. Or we could go ahead, all of these numbers, by the way, stay the same because it's still a radius of 3 and still a slant height of, a radius of 2 and a slant height of 3. But then we can use this formula right here of 90 minus alpha, and we can solve for alpha with that. So we know that this all simplifies to 12 is equal to 4 pi times sine of 90 minus alpha. And then remembering our complementary angles, we could also say that this is equal to 4 pi times cosine of alpha and use that as well. And so same thing up here, we could have written this problem as the volume is equal to 4 pi times cosine of 15, which is the original angle of deflection. So again, this problem instead we could have cosine of alpha and not even have to worry about theta, except a lot of times theta is what makes sense to us. Alright, so now that I went off on that tangent, we can go ahead and divide by 4 pi. And so this gives us 3 over pi is equal to cosine of alpha, which then we're going to do inverse cosine. So alpha is equal to inverse cosine of 3 over pi, which is going to give us the value of... Now, one thing about this, because we're taking... no, we still want this in degrees, so let's go ahead and just leave it in degrees. And we get 17.27. So I know in the past I said anytime you're dealing with pi, make sure you change it into radians, but this pi actually has to do with the circular base of the shape and not with the trig function itself, and so that's why we didn't switch. That's going on so much in my head, I about switched it, and then I realized, nope, that's because of the circle. Alright, so that's basically what 6.3 and 6.4 are covering over of solving the trig functions. Remember, a big key behind this is identifying your principal root, which is usually just in the first quadrant, or if it's a negative x, the second quadrant, or the fourth quadrant if it's a negative y value, I guess. But it's only in one quadrant, and then we use that knowing how to change from pi or change from minus 2 pi to get the negative angles, to be able to find angles within 0 to 2 pi. So just keep that in mind with these. A lot of it is still just using your algebra and arithmetic skills and then going from there.